Hi everyone, welcome to this video where we will understand the concepts of caching web and databases on AWS. So before we begin with today's video, let me give a quick introduction about myself. My name is Aishwarya Sood and I am working as a lead coach in the AWS domain, and I am 3x AWS certified, Amazon authorized instructor, and also an AWS Academy accredited educator. You can connect with me on LinkedIn. My profile name is given here. Also, you can scan the QR code to view my profile. So let me tell you what we are gonna cover in today's video. We will start by understanding what is caching and what's the need of it. Then we will understand a few points about database caching and a few strategies for it. And we will understand how Elastic Cache and DynamoDB Accelerator, that is DAX, can help for the same. And then we will understand about the session management, and finally we will talk about caching the data with the help of Cloudfront. So let's first understand what is caching. Let's say this is your home and this is a grocery shop. So frequently you are going there and the travel time between your home and your grocery shop is 25 minutes to bring everything. And that is quite time consuming. Every time you need a small thing also, you will go from your home to the grocery shop. But usually what you do, you have brought a lot of things in, like you have kept a stock in your home. Okay, let's say some 5 kgs of sugar and 5 kgs of salt or something, whatever you need, you have kept in your home, so that for frequent usage whenever you need, you do not have to go and travel 25 minutes to the grocery store. You can take it from your home only. So this is a kind of caching that you are doing. Means keeping the things in the stock as a temporary storage for the frequent access, because when you go from your home to grocery shop, it was taking 25 minutes to get these things, but now since you have these things at your home only, you have kept a stock, it will just take 2 minutes of yours to get these things. So the response time is quick. That's what is caching is. Okay, in the technical terms also, what will caching mean is, I will keep some data in the temporary storage so that quickly it can be retrieved. There can be certain types of data that can be cached, and few of the examples include frequently accessed data, the static data, and the data that requires quite slow and expensive queries. So today we will be discussing about the caching of web session state and the databases. Let's start with the database caching. Caching can be applied to any type of database, including relational databases such as Amazon RDS, or NoSQL databases such as Amazon DynamoDB, MongoDB, and Apache Cassandra also. The best part of caching is that it is minimally invasive to implement, and by doing so, your application performance regarding both scale and speed is dramatically improved. When building distributed applications that require low latency and scalability, there are a number of challenges that the disk-based databases can pose to your applications. And a few common challenges include the slow processing queries. Like, while there are a number of query optimization techniques and schema designs that can help boost query performance, the data retrieval speed from disk plus the added query processing times generally will put your query response times in double-digit milliseconds at best. Apart from this, cost to scale is another challenge that can be faced. Whether the data is distributed in a disk-based NoSQL database or vertically scaled up in a relational database, scaling for extremely high reads can be costly and may require a number of database read replicas to match what a single in-memory cache node can deliver in terms of requests per second, and the need to simplify data access. While the relational databases provide excellent means to data model relationships, they aren't optimal for the data access. There are instances where your applications may want to access the data in a particular structure or view to simplify the data retrieval and increase the application performance. So this is where the database caching comes up. Let's have a look at a few strategies how we can do the database caching. So database cache basically supplements your primary database by removing the unnecessary pressure on it, because it is going to hold the frequently accessed read data, so that once the query is processed, the result will be stored in the cache, and when the same request comes up next time, the response can be sent from the cache itself instead of processing it again in the database. The cache itself can live in a number of areas, including your database, application, or as a standalone cache layer. So the three most common types of database caches are these. First is the database integrated cache. Some database such as Amazon Aurora, they offer an integrated cache that is managed within the database engine and has built-in write-through capabilities. When the underlying data changes on the database table, the database updates its cache automatically, which is really great. There's nothing within the application tier that is required to leverage this cache. Additionally, there is DAX, that is DynamoDB Accelerator, which does all the heavy lifting that is required to add the in-memory acceleration to your DynamoDB tables without requiring the developers to manage the cache invalidation, data population of the cluster management. Another type of cache that we are having is a local cache, which stores your frequently used data within the application itself. This not only speeds up your the data retrieval, but also removes the network traffic that is associated with retrieving the data, making the data retrieval faster than any other caching architectures. But a major disadvantage with this kind of cache is that among your applications, each node has its own resident cache working in a disconnected manner. The information that is stored within an individual cache node, whether it's database cache data, web sessions, or users' shopping carts, cannot be shared with other local caches. But the majority of the disadvantages that are there with the local caching are mitigated with the remote caches. So let's understand what are remote caching. What is a remote cache and what is remote caching? So this is a separate instance which is dedicated for storing the cached data in memory. The remote caches will be stored on dedicated servers and typically they will be built on key value, no SQL stores such as Redis and Memcached. They provide hundreds of thousands of up to a million requests per second per cache node, and many solutions such as Amazon Elasticcache for Redis also provide the high availability needed for the critical workloads. Also, the average latency of a request to a remote cache is fulfilled in sub-millisecond latency, orders of magnitude faster than a disk-based database. So this was about the three main strategies or the types of database caching that you can have. Now we will discuss a little bit about DynamoDB Accelerator and then about the Elasticcache. Amazon DynamoDB Accelerator, or in the short form you can also call it as DAX, is a fully managed, highly available in-memory cache for Amazon DynamoDB that delivers up to a 10 times improvement in the performance from milliseconds to microseconds, even at millions of requests per second. And DAX will do all the heavy lifting that is required to add in-memory acceleration to the DynamoDB tables without requiring the developers to manage any kind of cache invalidation, data population, or cluster management. There are a lot of benefits of using DAX since it is a fully managed component, which means it will be highly scalable, flexible, secure. It is delivering extreme performance, all because these things will be built into the component itself since it is fully managed, and it's really easy to use because it is integrated with DynamoDB. DAX is designed to run within an Amazon VPC environment, and you can just launch a DAX cluster in your virtual network like this and control the access to the cluster by using the security groups of the VPC. So once it is all set up and configured, the data will start getting written to the DynamoDB and the cache will also be into action, and the reads will be happening from the cache so as to get the faster response times. Now talking about Amazon Elasticcache, let's understand a few basics of it. So Elasticcache is an in-memory data store that is available in AWS. It allows you to seamlessly set up, run and scale popular open source compatible in-memory data stores in the cloud. And since it is a web service, it is easy to deploy, operate and scale. And also it allows you to choose between two in-memory database engines, that is Memcached, which is a widely adopted memory object caching system, and the Redis, which is a popular open source in-memory key value store that supports data structures such as sorted sets and the list. It is used for retrieving the data from high throughput and low latency in-memory data stores, and it significantly improves the latency and throughput for many read-heavy applications workloads, for example social media, gaming or media sharing, improving the application performance by storing critical pieces of data in memory for low latency access. Also, Amazon Elasticcache is a popular choice for real-time use cases like caching, session stores, gaming, geospatial services, real-time analytics, and queuing. It offers fully managed Redis, which is voted the most loved database by developers in the Stack Overflow 2020 developer survey, and the Memcached for your most demanding applications that require sub-millisecond response times. Also, you can choose between Redis and Memcached based on your needs. There are certain special features with both, like Elastic Cache for Redis is highly available and Elastic Cache for Memcached is multi-threaded. So both have certain similarities, both have certain differences. It totally depends on your use case, that what engine you have to use with your Elastic Cache cluster. You can go for Elastic Cache for Redis, or you can go for Elastic Cache with Memcached. Let's understand a high level working of the Elastic Cache for all the internet scale applications, like real time applications in the gaming, media streaming, dating, social media, who need fast access, and also for the use cases like all the real time transactions, chat applications, BI and analytics, session store, gaming leaderboards and cache. Elastic Cache works wonders. It sits between your web servers and the database to serve the request faster by serving them from the cache itself. It can also be used as a message broker, and it stores ephemeral or the temporary data in memory for the quick responses. Now let's have a look at a few of the use cases of Elastic Cache. Then we will have a quick demo also for the Elastic Cache. So first of all, we can use Elastic Cache with our existing database to cache the frequently accessed records. It will ease the load of your relational or the NoSQL database, either Redis or Memcache engine, because of its high latency and the throughput. Low latency and the high throughput. And it can also be used with Amazon S3. And additionally, Elastic Cache for Redis can deliver query results caching, persistent session caching, and full page caching. Apart from this, it can be used to manage the session information. It can be used as a session store to manage the session information for both Redis and Memcached. The session management is commonly required for the online applications, including games, e-commerce websites, and the social media platforms. Apart from this, in terms of machine learning, we can use Elastic Cache for Redis in the use cases such as fraud detection in gaming and financial services, real-time bidding in ad tech, and matchmaking in dating and ride sharing to process live data and make the decisions within tens of milliseconds. Apart from this, in streaming solutions, we can use Elastic Cache for Redis with the streaming solutions such as Apache Kafka and Amazon Kinesis as a store to ingest, process, and analyze the real-time data. And Elastic Cache can be used for real-time analytic use cases such as social media, ad targeting, personalization, IoT, and the time series data analytics. So now let's have a quick look at how we can connect to a Elastic Cache cluster. Okay, so we will just go ahead to the AWS console. For this demo, I will not be starting all the things from scratch. Okay, if you want to see how to set up this Elastic Cache cluster from the scratch, okay, what are the security groups that are needed, what configurations you have to make, you can refer to another video on the same channel, which is Elastic Cache, Redis versus Memcached. So in that, everything in detail is mentioned. Right now, what we will be doing is, as of now, I have already created a Redis cluster, that is Elastic Cache for Redis, and I have already created an EC2 instance, and both are having the relevant security groups which can let these to communicate to each other. And I have also installed the Redis CLI on my EC2 instance. So I will show you how you can connect to this Redis cluster from your EC2 instance, so that you can use this for your different use cases and get started by using this Redis cluster. So for this, first of all, we will need this endpoint. Okay, so make sure you have this endpoint ready. This is where you can find it in the Elastic Cache console. When you go to Redis, you can just see whatever cluster you have created, it will be available, and you will be able to see the endpoint here. And then you just connect to your EC2 instance. Okay, so then we will be able to connect to our Redis cluster. So for this, we need to run this command. Okay, let me change the port number from here because it is on the 6379 port. This is the default port for Redis, and here we need to give the cluster endpoint which I was showing you here. So let us copy it and paste it here, and let me press enter. Now you can see I have entered into my Redis cluster, and now I can begin running the Redis commands, which means I have connected to my Redis cluster, and now I can start working on it. Now let me run a very basic command for it. Let's say I'm setting the A as 7 and enter. It says okay, which means the command has been processed. Now I will say get A. So it is returning me the value that I have set for the A. I can do one more thing, set B as 2 with the expiration period of 3 seconds. Okay, so now it is there. If I do get B, you can see nil, because within 3 seconds it has been vanished. Now if I run this command with the set B as 2 with the expiration period of 6 seconds, it is okay. Quickly let me retrieve it. Yes, it is there. Now after 2-3 seconds, if I run this value, if I run this command again, I will not be able to get this. Let me show you, nil, because I set the expiration period to this. So these were the basic commands only. Okay, you can explore it, you can use it for different use cases. My purpose was just to demonstrate you that how you can get started with it, how you can work on it. So to set up the whole Redis cluster and the EC2 instance, you can refer to that video which I just mentioned. And to connect to the Redis cluster, this is what you have to do. Just install the Redis CLI. One second, it got disconnected. You just need to install the Redis CLI on your EC2 instance. And once the Redis CLI is installed, you just need this endpoint and the commands that I gave there, and you will be able to start working on your Redis cluster then. So for now, let's go back to our slides because we have a few more topics to discuss in today's video. So now we will talk about managing the user sessions. What are user sessions? Let's say you are logging in into Facebook. Okay, you have entered your username and password, and let's say the Facebook session time is 1 hour. Okay, so let's say you entered your username and password, you made a request to access the Facebook. Your request went from here, it went to the load balancer, and randomly it has sent it to the second EC2 instance. Okay, and your session state information, that means your username, password and all the session details are stored on the second EC2 instance. Now next time, for the 1 hour that session is valid, but what you do, you just close the Facebook, and you after 20 minutes maybe you access it again. The session, ideally it is still active, but again you send a request here, it comes to the load balancer. Since load balancer is not sticking anything here, now it might send the request to the third EC2 instance, right? Because your session was stored on the second EC2, but there is nothing which lets load balancer to stick your session here. So it is just responsible for sending the request randomly, right? Now your request might be going to the third EC2 where your session is not stored. So it will ask you to log in again. Next time maybe it goes to the EC2 1, then also you will have to log in again. So that is not feasible. You need a good solution for this. So let's now talk about managing such user sessions using sticky sessions and few other solutions. There are various types to manage the user sessions, including storing those sessions locally to the node responding to the HTTP request, or designating a layer in your architecture which you can store those sessions in a scalable and robust manner. So common approaches include utilizing the sticky sessions feature of the load balancer, or using a distributed cache for the session management, which will be the elastic cache. With the sticky sessions, what will be possible is the users will be routed to the specific web server that is managing a particular user session. Let's say you requested to access Facebook and your session started, and all the session details were stored on the EC2 number 2. So if we have enabled the sticky sessions, so as long as the session is active, your request will be stick onto the second EC2 only. This load balancer won't take it to any other EC2 because your session's information is stored on the second EC2 instance. This is what sticky session can do, but it has a few disadvantages associated with it. One, it can lead towards an uneven load distribution, because maybe a lot of requests randomly got sticked on the second EC2 only, so there is less load on the first and third. So the purpose of load balancer is not getting served here. Then another thing can be the instance failure. Your session state is stored on the EC2 instance, but what if this EC2 instance fails? That session state information is lost. So that is another issue. That is why a better approach is to use a distributed cache or a persistent cache layer for the session management. So which can be achieved by using the elastic cache. So here what you do, you provision your EC2 instances using auto scaling. You can do this so that you have always enough EC2 instances, and you can also take care of the instance failure by using the load balancer and CloudWatch together with it. And if sessions that are stored on the nodes, session loss is at risk. Okay, because if EC2 fails, the session state information is also lost. That is why we have moved toward the elastic cache. So what we will do, we will keep this just for the application or website hosting itself, and for the session state information storing, we will keep it on a separate caching layer, that is a elastic cache, that is a distributed cache. There it will be persisted. So no matter even if a specific EC2 instance has failed, nothing will happen to the session state information. Whatever session state information they require, they can always get it from the elastic cache cluster that you would have created. So this is a solution for the persistent session management instead of storing it on the EC2 instances locally. Okay, so that was about session management, a few points. So I hope you would have understood it. Now let's talk about storing the data in caching servers across the world. So to store the data in the cache, there are two components available in the AWS global infrastructure, that is edge locations and the regional edge cache. Edge locations are also known as points of presence or the POP. Edge locations contain the data centers where the servers are used specifically for caching purposes. Okay, so they are nothing but a physical location itself where the data center is located, which contains the servers which are specifically used for the caching purposes, and they make sure that the popular content can be served quickly to your viewers. The other component is the regional edge cache. You can see it is marked by this orange color on the map. This bring more of your content closer to your viewers even when the content is not popular enough to stay at a point of presence, to help improve the performance of that content also. So both of these components, edge locations as well as regional edge cache, can help you in bringing your content closer to your users all across the world. What service is there that can help you in enabling all of these functionalities is the Cloudfront. Cloudfront is a global CDN of AWS, which stands for Content Delivery Network, which means it has a collection of caching servers present all around the world through which it serves the content to the end users for faster response times, which eventually improves the user experience. And to implement the content delivery network concepts that we have been discussing, Cloudfront is used. This service is used. It delivers the content through a worldwide network of the data centers, which are known as edge locations, which I just told you. And when a user requests the content that you are serving with the Cloudfront, the request is routed to the edge location that provides the lowest latency, which is nothing but the time delay, so that the content is delivered with the best possible performance. If the content is already in the edge location with the lowest latency, Cloudfront delivers it immediately, and if the content is not in that edge location, it retrieves it from an origin that you have defined. You can see here, origin can be any S3 bucket or maybe any HTTP server of yours. This eventually reduces the load on your application server because most of the time the request will be served through the edge location itself, and it won't have to go to the origin every time. Common examples of the origin are this S3 bucket, HTTP server, and that you have identified as a source for the definitive version of your content. So what you have to do to configure Cloudfront is just specify your origin, make sure you have some objects into them, create a web distribution in the Cloudfront, okay, and once you have configured it, you will get a Cloudfront specific URL. You just have to use this URL for the further access of the objects, and once the Cloudfront distribution is created, the Cloudfront's configuration information is sent to all the edge locations, not the data of these origins, but just the Cloudfront distribution configuration information is distributed to all the edge locations. Data will be there in the edge location once there's a request for that data. Now let us see how Cloudfront delivers the content. After some initial setup, Cloudfront works together with your website or the application and speeds up the delivery of the content. And once you configure Cloudfront to deliver your content, here's what happens when the users request the files. First of all, a user accesses your website or application and requests one or more files such as an image file or an HTML file. DNS routes the request to the Cloudfront POP or the edge location that can best serve the request. Typically, it will be the nearest Cloudfront edge location in terms of latency and routes the request to that edge location. After that, in the edge location, Cloudfront checks its cache for the requested files. If the files are in the cache, Cloudfront returns them to the user. If the files are not in the cache, then first of all, Cloudfront compares the request with the specifications in the distribution and then forwards the request for the files to your origin server for the corresponding file type. For example, to the S3 bucket for maybe image files and to your HTTP server for the HTML files. The origin server sends the files back to the edge location. As soon as the first byte arrives from your origin to the edge location, Cloudfront begins to forward the files to the user. Okay, like this. Now apart from this, Cloudfront also adds the files to the cache in the edge location for the next time someone requests those files. So when someone next time requests for the same data, it will be already present in that edge location and it will be served from there itself instead of going to the origin. Apart from this, the few things about regional edge cache, let me tell you. When a viewer makes a request on the website or through the application, the request is routed to the nearest edge location in terms of latency. That is what we have seen on the previous slides. In the edge location, Cloudfront checks its cache for the requested files, and if the files are in the cache, it returns them to the user. Otherwise, the request goes to the regional edge cache, the nearest regional edge cache to fetch the object. Then in the regional edge cache location, Cloudfront again checks its cache for the requested files. If these files are in the cache, Cloudfront forwards the files to the POP, that is the edge location that requested them. For the files that are not there at the edge location and not at the regional edge cache, Cloudfront will forward the request for the files to the origin server. And after the origin server sends the files back to the regional edge cache, they are forwarded then to the edge location and then to the user. So basically the main difference is that edge location has a smaller capacity and regional edge cache has a relatively bigger capacity, so that the data that is not very popular, that can be kept at the edge, so that that extra data can be kept at the regional edge cache and the frequently requested data can be kept at the edge locations. So that was about edge locations and regional edge cache. Now let's have a quick look at a demo which I have created, where I will demonstrate you the effect of caching and how the Cloudfront edge locations are working. So here's a demo that I have built using the Cloudfront. Okay, what we will be doing is just choose a file and I'll upload any random image. Let me upload this dog image. And let's see how much time it is taking. Slowly it will be uploaded to different regions. You can see it is uploaded in US East Ohio, South America and EU Stockholm and US West North California. So all the regions it is uploaded here, these regions. Okay, and now what I will do a download. This is first time download. You can see the time that it has taken to download for the first time. 0.21 seconds, 2.84 seconds, 3.33 seconds and so on. This is the time that it has taken. You can note it down. And when I do the repeat download, how much time it is going to take. Have a look. It is lesser than the time that it took for the first time. Okay, so it previously took 1 second, 2 seconds and so on. Now it has taken a little lesser time. So you can repeat the downloads and the time will keep on changing. Okay, so you can see it is lesser than the previous results. It will keep on changing. Okay, so it is almost all in the 0 seconds only. So this is because of the caching, because first time when I uploaded, it went to the origin in Amazon S3. After that, when I downloaded, it went all the way, it came all the way from S3 to the edge location and then to the user. Next time when I repeated the download, it came straight away from the edge location only. My request didn't go to the Amazon S3. In fact, it came directly from the edge location. That's why there was low latency. That's why I was able to get the response quickly. Okay, so this is how the CloudFront works. If you want to see a detailed explanation of how you can configure the CloudFront distribution and how you can set up Origin, you can refer to another video on the same channel which I have done previously, which is Amazon CloudFront 101. So you can check out that video for the detailed explanation for how to set up the CloudFront distribution. Okay, so this was just a quick demo to show you the effect of caching, that how it is able to provide you the low latencies. So I hope you have understood all the concepts that we have discussed today. We will meet in the next video. Thank you.